So it's just me in the shop today, so hopefully I get to show you guys a lot of what I'm doing, a lot of filming, but it's an interesting day because I got a lot of things to work on. I'm running parts, production parts on the machines. We're making 1,000 of these, or at the tail end of it, so hopefully I'll get them done today. Um, and I'll set up the other two machines, get those production parts running for someone else, and then some other maybe assembly parts. We've got some small things that need magnets put in and screwed together. And then we've got a new coolant pump for our Tormach lathe, which is exactly right below where you are, or up on our second level right now. But I got to make spacer plates because the pump we did get is a lot bigger than our old one. So we just need to make sure it has enough clearance to fit. So hopefully you guys get to see this all today.
So we've got our lathe here, and what we're gonna do is put adapter plates on our coolant tank, which slides right under here, feeds through all the piping and everything, comes out, shoots on our tools. On the inside, we've got our big turret, our spindle. Here's our block, which flows through all of our coolant. And we've also got blower tool in here. So, new pump, old pump. A little nasty, but very different in size and very different in weight also. So this one, I believe, is 1/10 of a horsepower, whereas this guy right here is 1/4 horse. So we're doubling our pressure, but with that means a lot more space. So in our coolant pump, in our coolant tank, I'm gonna make spacers, and they need to be able to fit around here, our housing, and sit everything up a little bit higher. Because our coolant tank is deep enough for our small one, not quite deep enough to house this, so we're just gonna raise everything up. I'm gonna be honest, I wasn't expecting to show you guys this today, but I'm running new parts. There's our 1/4-inch carbide end mill. And there's the tool holder it's supposed to be in. It'll focus. But that's not good. It was supposed to be attached. So I'll walk you through the process of what it's like changing these things out. So after doing some initial diagnosis, kind of looking at why it broke or potentially why it broke, probably just under too much stress. Tool probably could also just been worn, so it was having to put more cutting force or spindle load into cutting those parts, which eventually enough force to put into it. These tools, yes, they are carbide, tougher than the material that they're cutting, way tougher. Sometimes when they get dull, they just break. So what we're gonna do is just swap it out with a brand new one. And we got tons of these on hand because it's a very common size stuff to use. So we got our brand new 1/4-inch carbide end mill, 3 flute from Lakeshore Carbide. Their tools actually, we started to love them and ordered a lot from them because just the versatility and everything that they offer is great. So what I'm gonna do is I'm gonna take our collet, and because it's pretty gummed up, I'm gonna come back to the machine. You won't be able to see me, but I'm gonna clean out any gunk or anything that could be built up in there. Make sure to clean out our tool holder a little bit, our collet nut. It's a little built up in there, so run a paper towel in there, get some of that schmutz out of there. Still some in there. Come on. Something better. Still not great. Let's see if I got a small little pick or something in here to get all this out. Ah, there's a big chunk. This won't impede the tool's capacity to cut or anything, but it just helps make sure that when you do clamp it in the thing, in the tool holder, that it does spin concentrically or around the center of the tool holder, which is important to make not just roughing parts, which is what this tool does particularly. We have a rougher and a finisher. Our finisher parts do a lot less of the work. The rougher to take out the bulk of the material, termed roughing and finishing. So yeah, this was our roughing tool. So I'll put the collet back in the collet nut. And then if I remember correctly, which I should know off the top of my head, that the stick out for these, or how far it is from the collet nut to the end of the tool, should be 1 inch and 1/8. So I'm gonna grab our little tape measure or ruler, Measure that to 1 1/8 inch. Tighten that with our collet nut wrench. 3 ugga-duggas, and that is good to go. So now we've got brand new carbide tool in there. We'll go probe it so it knows that exact length. Carbide is sharp also, so duly noted. We'll load that in the tool, probe it for its length, and then get back to cutting.
So, tool behind me looks a little bit new. That's because it is. This is our new horizontal bandsaw. It is much larger and has a lot more features than our old one. See over here, it's made by Dado. It's a GA260W. All the different numbers and classifications for it. No clue what they mean, but I'll show you guys today some of the cool features on it, and this is also going to be used because really when we got this saw, we didn't really know how it operated. So if there are other people out there that have saws like this that maybe want to look for a guide or something that can kind of help them get started with it at least, I'm no expert on this saw, but I've come to learn how to use it in the past couple weeks. Yeah, weeks I should say, that are pretty cool and kind of nifty. So hopefully this helps. If not, then just enjoy looking at what I consider to be a pretty cool saw. So now we're kind of behind exactly where you guys saw me earlier, but I'd say one of the coolest things about this saw is that it can, based off a program that you write, cut a certain amount of pieces at a desired length. The way it's able to do that, because our pieces of stock are, when we get them from our supplier, they're about 12 feet long. Sorry. That's the air compressor pressure relieving. But as I was saying, our stocks from our metal supplier are about 12 feet long, and sometimes we just need to cut 2 inches, but most of our cuts are right around 36 inches. So this saw has 2 sets of vice jaws, basically, that clamp your piece so that when you're cutting it, it stays square and everything. It's got a back jaw, or its indexable shuttle jaw, and then the front jaw, which kind of surrounds right where the saw blade is actually cutting. So in your program, when you write however many cuts you want to do at whatever length, this indexable vise back here, or our shuttle jaw, is going to be able to move forward and backward. So it'll clamp up at the front, cut one piece at a desired length, open this jaw while it's cutting, move back to whatever desired length, and then once it's done cutting, the front jaw will release, this back jaw will clamp tight, and then everything will shuttle forward. Now this only has about 16 inches of travel, and if you've heard me say, we've got some parts, most of our parts really, which are right around 36 inches. So this will actually open and close, move the parts forward about 3 different times, indexing each time. So it's a pretty nifty thing, and for some parts where we're making, I don't know, 160 per batch, it's kind of nice rather than sitting there and pressing the cut button 80 times. If we have 2 sticks stuck together, we'll do bundle cutting. You can just write a program for it and it'll do all the cuts. We'll check every 5 or 10 just to make sure we're getting the right length, but saves a lot of time, saves us a whole lot of trouble so that we can keep programming or keep machines running.
So I'm just standing next to the camera. I'm about to turn the hydraulics on, so it might get a little loud, but you guys will be able to see what those indexing jaws look like and how they move. So I'm going to turn our power on and then just lift the saw blade up and then start moving the jaws around just so you can see what that motion looks like. So this is our back jaw, moving forward and back. Same thing with our front jaw. These will close and then open, really with just a 1/4 inch of travel, half inch of travel, so we can clamp tons of different size pieces. But the way this would index when it's making multiple cuts or following a program, I would close my front jaw like so. While it's making that cut, the back jaw or the indexable jaw will release. It'll move all the way to the back or whatever desired length I want, close on the material or sticks of material I have in there. Once this saw blade cuts through the material in the front, it will come up. The saw blade in the front will release, and then the shuttle jaw in the back will move all the way forward to whatever desired length I set my part to.